This video is going to review imaginary and complex numbers and then systems of equations. Remember that imaginary and complex numbers deals with an I, which means that we have a negative under the radical. So if I have anything negative under the radical, it's going to give me an I. So if I have -4 under the radical, that's equal to 2I. If I have something like -6 under the radical, it becomes I radical 6. But remember that our calculator can do most of this work for us. And then with systems of equations, you want to remember that if it's asking for the solution to a system, that's going to be a point, x comma y. If it's asking for the solution to f of x equals g of x, that's going to be x values only. So those are just some general things to keep in mind before we jump into the problems. Express in simplest a plus bi form, xi parentheses 2 minus 3i close parentheses squared. So remember that we can't put variables in the calculator, but everything aside from the variable can go right into the home screen of my calculator. So all of this I'm going to put in the calculator. I'm going to leave my x on the outside, and whatever I get, I'm then going to distribute into. So in the home screen, I'm going to do I, which is second decimal point, 2 minus 3i, close my parentheses, squared. And I get 12 minus 5i. So this part went in the calculator. And then when I distribute into that, we get 12x minus 5xi. Number 2. If b equals 7 plus I and c equals -5 minus 6i, where I is the imaginary unit, find b minus 2c. So the first thing I'm going to do is substitute in b minus 2c. Notice how I'm using parentheses. Anytime we substitute, we use parentheses. There are no variables, so this entire thing is going to go exactly as I see it in the home screen of my calculator. 7 plus I minus 2 times -5 minus 6i. 17 plus 13i. Number 3. Which expression is equivalent to I to the 233rd power? So in my calculator, I can go right in the home screen for most I powers. This one gives me an error because I have that E and that funny looking answer. But if I had something different, like I to the 23rd, it gives me an answer. But when you get this funky looking E answer, you're going to hit math, go to the right, and go to ipart. And then I'm going to put I to the 233rd. And we get a positive I. So math, go to the right and choose ipart. Number 4, simplify in a plus bi form, 2x times 3i squared. So once again, I have a variable, but everything aside from the variable can go in. I'm actually going to leave the 2 and the x on the outside, just so I don't forget about that 2 or use it twice by accident. And I'm going to put this piece in my calculator, just the 3 minus I squared. But there's other ways to do this where you could put other pieces in. As long as you're consistent and you keep track on your paper of what you put in versus what you didn't. So I have 8 minus 6i, and distribute in, we get 16x minus 12xi. But like I said, you could have put in the 2 if you wanted to. So if you put in 2 times 3 minus I squared, then you would only need to distribute the x in. You end up with the same answer of 16x minus 12xi. Number 5, find the roots in simplest a plus bi form. Roots in simplest a plus bi form tells me a few things. The first thing it tells me is there must be an I in the answer. And we talked about this earlier, we get an I from a negative under the radical. When we're solving, we get radicals from the quadratic formula. So I'm going to be using x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, whenever we use the quadratic formula, whether there's i's or no i's, it has to be equal to 0 before I can identify a, b, and c. So my first step here is going to be to add 11 to both sides. The right side's going to cancel and I'm left with 0, which is what I wanted. The left side, I'm going to get x squared plus 6x plus 11. Notice how I ordered it in standard form. There were no like terms. So that means we have a equals 1, b equals 6, and c equals 11. And we can go right ahead and substitute into our formula. I like to set everything up first with open parentheses for all of the variables I'm going to be replacing. Negative b plus or minus b squared minus 4ac all over 2a. We get x equals negative 6 plus or minus the square root. I'll come back to that in a second. In my denominator, 2 times 1 gives me 2. Remember that not the radical, but everything underneath the radical goes in the home screen of your calculator exactly as you see it. So open parentheses 6 close parentheses squared minus 4 times 1 times 11. So we end up with a negative 8 under our radical, which is what we had predicted because we knew that we were going to have a negative, which meant we had an I. Negative 6 plus or minus 2 radicals. I'm going to break this down because you cannot take the square root of 8. If I go to my calculator and I try to take the square root of 8 or the square root of negative 8, right now I have a non-real answer. It's coming back as an error. If this happens to you, you want to go to mode and make sure you're in a plus bi form. So let's try that again. If I take the square root of negative 8, I do get an I, but I get an ugly looking decimal, and we never want decimals as part of our answers. So I need to break that 8 into 2 pieces. If you need to, you can go to the y equals part of your calculator, type in 8 divided by x, go to your table. My options are 1 and 8 or 2 and 4. So I have a 4 and a 2. I like to make my perfect square the negative because now when I go to the home screen of my calculator again, not only can I square root 4, but I can square root negative 4 to get 2i. So we have, hold on. We have negative 4 and 2. So that gives me negative 6 plus or minus 2i radical 2 all over 2. Remember, at this point, you cover up the radical. If there's something that they can all be divided by, they can all get divided by 2. So my final answer is x equals negative 3 plus or minus I radical 2. So that's all about imaginary numbers. We have 2 more questions to go for our systems of equations. So for number 6, given f of x equals the absolute value of x minus 4 plus 2 and g of x equals 3x minus 4, find the solution to f of x equals g of x. So I mentioned this earlier, f of x equals g of x, I'm looking for x values only. So that means choices 1 and 2 are gone automatically. In order to find this, we want their point of intersection. So I'm going to put each equation into the calculator, the first one in y1, the second one in y2. To get the absolute value, alpha, window, enter. x minus 4, make sure you hit the right arrow to get outside of it, plus 2. And then I have 3x minus 4. Hit the graph button. Remember, if you ever get a funky looking window, zoom 6 brings you back to your original window. Second trace, choice 5. Scroll over to your point of intersection using the right or left arrows and hit enter 3 times. My point of intersection is x equals 2.5 and y equals 3.5, but I was looking for x values only, so my answer is choice 4. And just in case you want to write it down, second trace, number 5, those were our calculator steps. Last question. Solve x minus 2 squared plus y plus 3 squared equals 4, and x minus y equals 3. So I have a circle up top and a line down below. We want to substitute our line into the circle, which means that this piece here has to be x equals or y equals. So I'm going to start by adding y to both sides. I get x equals y plus 3. And then I'm going to take this this x and plug it in up here. So instead of x minus 2 squared, we're going to have y plus 3 minus 2 squared. And then you want to simplify, if possible, inside your parentheses. So 3 minus 2 gives me 1. So I have y plus 1 squared as my first parentheses. And then remember that a binomial squared really means this is y plus 1 times y plus 1. And this is y plus 3 times y plus 3. So we should be doing the box method for each of these. Pause the video, give it a try on the side on your own. And then when you're ready, hit play, and I'm going to have the answers to the box method filled in. So our first box method should give us y squared plus 2y plus 1. The second box method should give us y squared plus 6y plus 9. And then we still have our equals 4 on the right side. Now we're going to combine like terms at this point. I have 2y squared plus 8y plus 10 equals 4. Anytime we have a squared term, in this case I have a y squared, I want it to be equal to 0. So I'm going to subtract 4 on both sides, crossing out the wrong side. On the right side, we get equals 0. On the left side, we have 2y squared plus 8y plus 6. You want to factor, but notice how everything here can be divided by 2. So I'm going to do that first to make my numbers easier to work with. Y squared plus 4y plus 3 equals 0. At this point, we're going to factor. I'm going to use AM, so 2 parentheses, a y in each. Bring down my first sign of a positive. A positive times a positive is a positive. I'm multiplying to 3, so if you need to, go to the calculator, but the only options are 1 and 3, which works out because that does combine to 4. Y plus 3, y plus 1, t off. We get y equals negative 3 and y equals negative 1. But remember, this is a system of equations. So my final answer needs to be x comma y. So right now, I have the y's, but I need to find the x's that go with it. So you're going to substitute in to your line, or the simpler of the two equations. So we had x equals 3 plus y. So x equals 3 plus negative 3. That gives me 0. So my first coordinate is 0 comma negative 3. Same equation, x equals 3 plus y. 3 plus -1, that gives me 2. So my second point is 2 comma -1. So this conic linear system of equations, which is a circle and a line, has two solutions, 0, -3, and 2, -1.